Tutorial over 4.1 Graphing Quadratic Functions. Here's a list of your vocabulary we will go over today. Quadratic function, quadratic term, linear term, constant term, parabola, axis of symmetry, vertex, maximum value, and minimum value. First, let's kind of talk about what a quadratic function is. Remember that your parent function is y equals x squared. That's a quadratic, and it's a U-shape. Okay, so that's what we're dealing with. We're dealing with a parabola. Okay, that's the shape. Axis of symmetry, again, if you cut this shape in half, it's exactly where it would fold on top of each other. The vertex is this little corner point here. And when we say maximum value, if we have an upside down parabola, we're going to end up having a max value. If we have a right side up parabola, we will have a minimum value. For the maximum value, you can think of this as a mountain, and for the minimum value, you can think of that as a valley. Okay, so let's try our first example. We need to graph f of x equals x squared plus 3x minus 1 by making a table of values. Alright, so it doesn't matter which numbers you choose, but the best ones usually are a couple of negative numbers that go through 0 and 1. So I'm going to put a table up here and just choose some random x values. And it doesn't matter how many points you choose, you want to choose enough so that way you can actually get a good curve. Alright, so once you choose your x points, you want to plug them into your original function so you can figure out what y values you have to use. So here we're going to use parentheses, negative 3 squared plus 3 times negative 3 minus 1. Now, when you actually put that in your calculator, you have to make sure you have parentheses. You get, so the point we're going to graph is negative 3, negative 1. And then we're going to do the same thing for negative 2. We're going to plug it in everywhere we see an x. And we get negative 3. And that means we're going to plot the point negative 2, negative 3. And when we fill out the rest of the table, we get the following points. So now we're actually going to plot these on the graph and connect them with the smooth curves. And we should be able to see how the curve should look. Alright, so I got rid of everything but my coordinates that I need. So negative 1, 3, negative 1. We have negative 2, negative 3. We have negative 1, negative 3. 0, negative 1. And 1, 3. So you see this nice curve here. You should be able to connect the dots like so. And put arrows on the end, and there's your graph. Alright, so here's a key concept. Here's a quadratic. As you can see at the bottom where you have a minimum is called our vertex. The line down the middle is called the axis of symmetry, and this is actually a formula we're going to use, x equals negative b over 2a. If you actually look at our parabola, you always have your x squared term first, and the coefficient in front of it is going to be considered a. So if you had just an x squared, the coefficient would be 1, and a would be 1. Okay. Bx, it means the x by itself, the number in front of that x is called b, and then when you have a constant by itself, it's called c. And that'll make more sense once we actually do an example. The y-intercept, if you replace x with 0, you should be able to find where your parabola crosses the y-axis. The equation for the axis of symmetry is x equals negative b over 2a. So you're going to take your middle term here and put it over 2 times your first coefficient. And you have to make sure that these are in the correct order, from the 2 as the exponent down to the x with a 1 exponent, and then with your constant. And it has to be in descending order, or else this won't work. Okay? And then also the x-coordinate of the vertex will happen to lie on the axis of symmetry, so we'll use the same formula using x equals negative b over 2a. Alright, so example 2, it says consider the quadratic function 2 minus 4x plus, that should be x squared, let me fix that. And it says we need to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Well, before we can do anything, we have to rearrange this formula. We have to make sure that the x squared term is first, then we have our one term that has the x by itself, and then we have our constant last. So really, when we rewrite this, we should get f of x equals x squared minus 4x plus 2. Now it's written in the correct order. Now, to get your a, b, and c, the coefficient in front of your x squared term is a. The one in front of your x by itself is b, and the constant is c. So, we know that a is equal to 1, b is equal to -4, and c is equal to 2. Alright, so the first thing it says find the y-intercept. Well, if we let x be 0, we have c is 2, so that means our y-intercept is going to be at 2, okay, because of this value right here. Next thing, we need to find the equation of the axis of symmetry. So we're going to use our formula, x equals -b over 2a. And then we're going to plug and chug. So we know that b is -4, so we have -4 over 2 times, and then our a is 1. When we reduce that, we get 4 divided by 2, which is 2. So the equation of the axis of symmetry is x equals 2. So x equals 2. Now it says find the x-coordinate of the vertex. Well, we've already done that by -b over 2a. So x equals 2 would also be my answer to my third question. The next piece, it says consider the quadratic function and make a table of values that includes the vertex. So let me actually fix that equation again. So just like we did on the first example, we're going to have to make a table of values. We need to make sure that we include x equals 2. So I just chose the numbers 0 through 4, and we're going to plug in just like we did on the first problem. So I took the liberty of just filling this out for you. And here's your vertex. So from here, with these 5 points, we should be able to get a pretty good looking graph. So if we think about everything that we found from A and B, we should be able to make a pretty good looking graph. So I went ahead and plotted the points. So now we're going to draw this nice smooth curve as best as I can with my thing. And there's your graph. Alright, so let's talk about maximum and minimum values. The way you can tell whether, sorry about that, you look at your A value. If the A value is bigger than 1, so like 1, 2, 3, 4, and above, that means it's going to open upward. So that means you're going to have a minimum value. Now, if you have a value that's negative, it means it's going to open downward, and that means you'll have a maximum value. Alright, so on A it says consider the function f of x equals -x squared plus 2x plus 3. And it says determine whether the function has a max or min. You can actually just look at this and see that since it's a negative number in front of your x squared, it's going to open downward, and that means you're going to have a max. Now, if you wanted to, you can always plug that into your calculator, and you could see that it has a max value. Alright, so B, it says consider the function f of x equals -x squared plus 2x plus, oh, that's the same one. That's okay. Plus 2x plus 3, it says state the maximum or minimum value. Okay, so in this case, we can actually do -b over 2a. And this is going to give me my max or min. Now, when it actually asks for that value, it's asking for the height. So that means you need to find the y value. Okay, now this will actually give you your x value. you find your x value, you plug it back into your original equation, and that'll actually give you your answer. Alright, so we look at our quadratic. We need b, which is going to be the second number. So we have negative, and then we plug in 2 over 2 times a. Well, our a is in front of my x squared, and it has to be a negative 1. So negative 2 over 2 times negative 1 is just 1. Plug that into our original equation, we get negative, parentheses, x squared plus 2 times 1 plus 3. And we get our answer of 4. That's our answer to B. And the last one says consider the function. Same thing. State the domain and range of the function. Well, we know that a parabola is all real numbers for the domain, always. And the range, depending on what it looks like, well, we know it has a maximum value, and we just found our max value. Our max height is at 4, so that means it's going to go from negative infinity, and it's going to stop at 4. And it is going to be inclusive to 4, so we use a bracket. Alright, for our last example. A souvenir shop sells about 200 coffee mugs each month for $6 each. The shop owner estimates that for 50 cents, and for each 50-cent increase in the price, he will sell about 10 fewer coffee mugs per month. How much should the owner charge for each mug in order to maximize the monthly income of their sales? Usually, anytime you see something that says maximize, you need to think of an upside down parabola. Okay? So actually, let's think about this in words. We know that the income is going to equal the number of mugs times the price. So let's actually get some variables. We're going to let x equal the number of 50-cent price increases, and we're going to let I of x equal the income as the function of x. So now let's actually write the equation. Well, first we need to figure out the number of mugs. We have a total number of 200 coffee mugs. And we know that every time we have a price increase, it drops by 10, so we're going to subtract 10x. Okay, so this is the number of mugs. And I found that information right here, the 200 coffee mugs and the 10 fewer coffee mugs per month. Okay. Next piece of information we need is the price of each mug. So we have our $6 each, plus when we do our 50-cent increase times x. Okay, so that's each time that we increase. And again, that represents price per mug. And I found this information here, $6 each and 50-cent increase. Now we need to actually write that as an equation. So we have our income, which we let be I of x, and that's going to equal the price of mugs, which we just said is 200 minus 10x, and we're going to multiply that by the price per mug. So now we actually need to get this in standard form, that ax squared plus bx equals c. So to do this, first we need to do what's called FOIL, and that stands for first, outer, inner, last. Or you can call it double distribution. Okay, so we're going to take 200 times 6, then 200 times 50 cents, then we're going to take negative 10x times 6, and then negative 10x times 0.50x. Now we're going to simplify. 200 times 6 is 1200. 200 times 50 cents, or sorry, I forgot my x there, is going to be 100x. So plus 100x minus 60x minus 5x squared. Remember, when you have two x terms, you're going to it's going to make x squared. Now we actually need to simplify and combine like terms. So we get 1200 plus 40x minus 5x squared. Now we need to rearrange this to where we have our x squared term first, we have our x term in the middle, and then we have our constant on the other side. So we get I of x is equal to negative 5x squared plus 40x plus 1200. Alright, so to find our maximum value, we're going to use the x equals negative b over 2a, where we have b is 40, and we have a is negative 5. So we plug in negative 40 over 2 times negative 5, and that gives us 4. So if you think back to what we let x be, that means the coffee shop should make 4 price increases of 50 cents to maximize their income. So if we take that number and we plug it in to 6 plus 0.5 times 4, so 6 plus 0.5 times 4, we end up getting $8. So we know that the coffee mug price should be $8 in order for them to maximize their income. Thanks for watching.